Okay. So first of all, before I start babbling, everybody can go into Blackboard if you're going to follow along in class today. If you just are going to do the thing later on, rewatch the video or something. I put a new link up here on Blackboard over on the left. It says Java JSON library. So rather than writing our own way to parse JSON, which would be an interesting thing, but might take us several class periods, I'd rather just get the data in so we could start looking at searching and sorting the data and that kind of stuff. Ultimately, it's going to be the same thing. We'll look at some of the complexities that we would have run into. We just won't actually write the string parsing aspect of it ourselves. We'll get plenty of that. Go ahead.
What happened to parsing the data because it's more fun?
Huh?
What happened to doing it ourselves because it's more fun?
It would be more fun, but we're still going to do other fun stuff. It's going to do the same stuff. This is more of a time thing. I want to make sure we get the content in that I want to get in. Okay. Yeah, we're not going to miss any things we would have done. We're just going to do string parsing with the data we're getting rather than some other stuff. So if you go into the JSON library thing, there should be a file down below to download called JSON simple 1.1.1 jar. So just download that, put it in your downloads folder, put it in your desktop. I don't care where you put it, but put it someplace you can find it. All right. Now, before I go any further, I'm going to show you how to link this into your Eclipse because this is a two-step process. So bottom line is that there is not a built-in JSON library in Java, which means Java does not contain a tool that allows you to parse through JSON data conveniently. That's mostly a truth. They actually have something called serializable, and they have something called, what's it called? Array maps, maybe? That kind of work that way. But let's just assume for the sake of this argument, that doesn't exist in Java. But the good news for us, just like we were going to do, somebody's already written a JSON library that you can feed it a string and it will pull all the data out for you. So you can just start using the data. So we want to, instead of reinventing the wheel, we're going to go to Home Depot. We're going to find somebody else's tool that already knows how to work with JSON data, just like we're using somebody else's data, right? We have our single program. We pulled somebody else's JSON data in, and now we're going to take somebody else's tool that just knows how to conveniently work with that data. We're still going to be writing all the logic in the middle, but we got these tools. So this JSON simple library, jars are Java archives. So the inside of this guy, there's going to be some Java classes that somebody wrote and things like that. All right, so download it, put it somewhere that you can find. Now, when you go into Eclipse, and don't worry about the stuff you see on the screen right now. It's just setting it up before class so we can work through it relatively quickly. And I have updated it on GitHub. So if you refresh the GitHub screen for my GitHub repository, you'll see the current code we're going to be walking through today. So once you're in your Eclipse project, so just be in the project, click on, go into driver or something like that. Up top on Windows, it'll be part of the window. And on the Mac, it's part of the top bar. There should be a menu called project. Click on project. Click on properties, and I say this inside the file download thing too. Now over here on the left, you have something called Java build path. And then there's a bunch of tabs. It might be that libraries is already selected, but the tab you want here is the libraries tab. All right, inside here, we have something called module path as well as class path. We're not using modules for our code, so you'll want to click on class path. And then over here on the right, you say add external jars. And then you're just going to go and browse to wherever you saved that, that file, that jar file. All right, and you'll hit open, and then you'll hit apply and close. That will now give your Java project here access to that simple JSON library. All right, so we got that tool. We can now start using the tool. All right, so I'm gonna comment some stuff out here just so we can remind ourselves of some stuff. All right, so we've previously written this object called URL reader, right? And we can go into our URL reader. I made this guy public just for the sake of my testing. So inside here, the constructor for URL reader goes ahead and sets that string and then calls a function that we wrote called read from URL. Here's read from URL. It is a private function, so it's only accessible inside of the URL reader class. Good news is we are currently inside of the URL reader class. So this guy goes and does that magic of hitting that website, grabbing the string, bringing it down, and ultimately it sets our variable URL contents equal to whatever we read from the internet, the big long JSON string. Okay. Now, because this URL contents variable is private, we cannot access it external to this class. So if I try to say, let me copy this. If I try to say this guy dot, then what was it called? The contents, something like that. And I hover over this, notice it says that it's not visible. It knows it exists because Eclipse can go and look in that other file. It knows it exists, but it says, look, you made this guy private. I can't access it. But we made it private for a good reason. We don't want people to externally be able to go and manipulate that variable. You know, the idea is that our URL contents holds the contents of the website up there. We don't want somebody externally to be able to go in and change that string to say woot or something like that. All right. So we want to have it locked down, but I do need to get access to the string. I need to get read-only access to that string out here. And we do that through getters and setters. Well, in this case, we do it through a getter. So inside of URL reader, I'm going to write a method. I'm going to show you two different ways of doing this. We're going to write it by hand because it's nothing special. It's just a normal method that happens to return a private member. So I'll make this guy public. We'll call this get contents. And this guy will return this dot the URL contents. And the type of value he's going to return is a string. So this is a public method that is accessible outside of this class. And what he's doing is he's returning a string. What string? The string that is contained inside of the URL contents, which is a private string, which says you can only access it inside of the class called URL reader. Well, it so happens I am in the class URL reader. So this guy is allowed to access this string. He is then returning a copy of that string external to this class, which will give somebody else read-only access to it. They can't call this function. They can't come out here in driver and do, equals woot. They can't do that, right? This guy boils down to the string that is the contents of the URL. So we've given ourselves read-only access to that private field. Make sense? Nothing special about getters or setters. They're just functions that happen to manage the access to the fields, the private fields of our classes. So in our case, a URL reader, it's going to manage the contents of that variable through its relationship with the cloud, with that website. but we need to be able to get the contents of it for reading purposes only because we're going to use it for some other stuff. All right, now a cool little shortcut that Eclipse gives us, because this is something that's pretty common. Here in URL Reader, remember when we first started writing some classes in here, I mentioned always make everything private and then loosen the reins if you need to, if it makes sense to do so. And we'll see some examples where that might make sense. Well, a little convenience thing you can do here is inside of Eclipse, if you just go somewhere in your code where you want to put it and you just right click and you go to source, and then there's a thing called generate getters and setters. This is similar to the thing I showed you a couple classes ago where when you're creating a new class, you can tell it to go ahead and create main for you. So once you're used to writing these things, once you appreciate that they're not difficult to write, it just can be a little tedious for something, you can go to generate getters and setters. It'll show you your two fields here. And for us, if you hit the drop down, I want to give myself read-only access to the URL contents. So I'll just hit the checkbox next to that guy, get the URL contents. Go ahead and hit generate, and it puts that function in there for you, which you'll notice is identical to the function we wrote a few minutes ago. And you can name it whatever you want, but typically when you're getting the name of a private field, you'll say get whatever the name of that field is. It's just naming convention. Okay, so it's not doing anything special. It's not linking some weird behind the scenes thing. It just created these 4 lines of code for you. That's it. All right. Any way you cut it, outside of that, we now have access to the URL contents. All right. Now, as just a reminder, what does the URL contents hold? I'll just do a system.out.println on this guy. And what we should see here is our wall of JSON text, the stuff we read from the website. So I'll go ahead and run this. And there's our bunch of JSON stuff, right? That's the data that we want to pull the stuff out of. It's stored in a structured way in JSON, which is great for sending it between programs, right? We sent that in, we grabbed the information from that website. So that website has a program that outputs that JSON. We have a program that wants that data. A convenient way of sending that data is in this JSON format because it has structure to it. Now we have that structured data, but we need to do something with it. We want to be able to pull the actual, the names of the cards, the cost, all that stuff. We got to extract that stuff from that JSON data. It was in a really convenient way of sending it from point A to point B. Now I have it, and it's not all that convenient for us now that we have it. All right. So we're going to use this tool that we just, let's say, installed. So up top here, I've imported a couple things. So I've imported org.json.simple JSON value, JSON array, and JSON object. Last time we kind of named our JSON value thing, we named it JSON pairs. So the type of JSON object we're dealing with here is a bunch of name value pairs. If you remember at the end of class last time, we kind of created some empty classes to hold these things. All right, so I'm actually going to back away from that for a bit. I'm going to just come into the source folder here. I'll close these guys. We're going to use this built-in one. So I'm going to get rid of JSON array, JSON object, JSON pairs, JSON parser. I'll right click on that and say delete. Okay, so now we have removed our starting point for our own parser, and we went ahead and downloaded that jar file, brought it into our project in Eclipse. So now our project can now use that third-party tool for dealing with JSON. So now we're going to learn how to use that tool. So I'm going to go ahead and comment out this line. We're all convinced that we are able to read from the URL contents. We can get it from the website. We get this wall of JSON. So we know that this guy's good to go. I'm going to go ahead and steal this here real quick. So when we use something called JSON value. So it's a tool that came with that new library that has a function in it called parse. We started talking about this last time when we were getting ready to write our own JSON parser. So it has a function called parse. Now, I'm calling this function with the name of the class that function is defined in, which means if I were to go and open up that jar file and were to go and look inside of JSON value, that Java file, I would find a method called parse, and it would have the keyword static in front of it because it's a method that's owned by the class. I know that because of the way I'm calling it here. Static methods or class methods are called using the name of the class in which the method's defined. Why do we suspect this is the name of a class? Why do we think what I have highlighted there is likely the name of a class? Capitalized. Yep. So this ultimately comes down to naming conventions. You know, Java is not going to scream at us if we make all of our classes lowercase. Java doesn't care. A good programming practice typically says classes start with an uppercase character, methods start with a lowercase character. Variables start with a lowercase character as well. Again, naming conventions. Okay. So I'm going to go ahead and use this tool called JSON value. We can think of it like we went to Home Depot. We got this thing off the shelf. We unboxed it and we see that there's one button. And that button says parse on it, okay? And that button requires me to insert one thing to make it work. What do I need to give it? I need to give it the string that's in JSON format that I want it to parse. And how do we get that string? We ask our Hearthstone URL reader to get the URL contents. That's the method we just finished writing. Well, actually, in this case, we let Eclipse generate it for us, but we wrote it before that. So this guy right here, that will boil down to a string. The specific string will be the wall of JSON text that we downloaded off the internet. So far, so good? All right, so now we've used this tool to parse through this. The magic has occurred at this point. And now we're going to prove it to ourselves. So first of all, I'm just going to print out this object. Object is a generic. This is a generic object because we don't know. We talked last time that JSON comes in a couple of flavors, right? We can get a JSON array. We can get a JSON object. So a JSON object, or we called them JSON pairs last time. That's the curly bracey thing with a bunch of name value pairs in it, kind of like a Python dictionary. Whereas a JSON array is kind of like a Python list where we have the square brackets. So they are both JSON, they're both legal JSON values, but they are different kinds of things. So JSON value.parse is going to return some kind of JSON value. I'm storing it in a generic variable here called obj, but it's of type object. I didn't have to do it this way. This is more of stepping through it and showing you that, hey, here's the starting point for this guy. So now when I run this, you're going to see that that object outputs the stuff it read in. Okay, no harm, no foul. From my perspective, this guy didn't do anything, right? I still see the same output. You might notice it actually looks a little cleaner, the format of it right now. Doesn't matter. From at a glance, it just, it didn't do anything to the text. Now I'm going to do this. I'm going to say get class. Notice that even though I put it into a generic object, you know, because a generic object knows how to hold any kind of object. We talked about inheritance last semester. At the top of the inheritance tree, you have object. Then you have objects that you create. Then you have the objects that you inherited from. So like we created our little mud last semester. So we had, we created what do we do it? Like an inhabitant class, I think. And we had two different kinds of inhabitants. We had monsters and we had players. So that hierarchy was a player was an inhabitant, which was an object. A monster was an inhabitant, which was an object. Nothing goes above object. Object's like our starting point in all object-oriented languages. So I'm saying, look, whatever this guy returns, I know for a fact I can hold him in this box. Because regardless of what kind of animal it is, it'll be an object. I think with simple JSON, the hierarchy actually is you have JSON value. There's two kinds of JSON values. You have JSON array and you have JSON object. So we actually could have put this inside of a JSON value instead of a generic object. So the hierarchy would be JSON array, which is a JSON value, which is an object. JSON object, which is a JSON value, which is an object. Okay, I'm just bypassing the middleman and saying, I'm not really sure what the hierarchy is in there. I didn't look at the documentation. So look, this guy's going to return something. And actually, if you look at it, if I say JSON value dot parse, it actually does return a generic object. But that doesn't mean I couldn't have put it into something more specific. All right, so I'll go ahead and just catch it in this very nice generic object container. But notice here in this next line, I told that object to just tell me what kind of class you actually are. What are you really? And he advertised for me, don't tell anybody, but I'm actually a JSON array. And we remember when we looked at our the JSON output that we got from the cloud, that everything's inside of the square brackets, right? That's the kind of animal we're dealing with, is a bunch of JSON objects separated by commas inside of a list. All right, so this guy is a JSON array. So we could even bypass this and just kind of at the very beginning, well, I actually do it in my code here. So notice the very first next line I do is I just go ahead and create a variable called array of type JSON array. And I put my object in there, but I do what's called typecasting. I said, look, I just proved you actually are a JSON array. You might have a mask on that pretends like you're an object, but you're a JSON array. You told me so right here, right? Okay, and here I'll show you another, we can say instance of JSON array, like that. I'm gonna put my comment back in. So there's another Boolean operator called instance of, and this guy returns true if whatever's on the left is an instance of the object type on the right. So in this case, we expect this to be true, right? We just printed it out. We saw evidence here that, hey, object sure thinks he's sure advertising himself as he's a JSON array. So I would expect if I were to ask object, are you actually an instance of JSON array? I would get a Boolean true out of that. So here's my Boolean true. Let's go ahead and throw that in the slides here. And we will be using that instance of here pretty soon. So instance of is a Boolean operator. The syntax is object, well, here, I'm going to put this on the second line. Object, instance, and then instance of, all lowercase. Class name. And this guy returns true if object instance is indeed an instance of class name. Returns false if object instance is an instance of some other class. Make sense? So the real life version of this would be us walking up to somebody and asking ourselves, what are you? All right. So for instance, let's say Zach walks up to me and says, is Littman an instance of a gymnast? Clearly the answer would be true. I'm clearly a gymnast. Zach won't even make eye contact. You don't think I could be a gymnast? I was on a Zoom call this morning at 7:30, and I told him I get up like at 5 a.m. and I told him, yeah, I was up at 5 a.m. and I already ran 4 miles today. This is a call with like 14 people on it for this project we're working on in Madison with Aurora WDC. Every one of them started laughing. Nobody believed I went for a 4-mile run this morning. I'm going to add a little bit to next month's bill for that. I could do 4 miles as long as it's all downhill. Let momentum carry me. All right, so this instance of operator allows us to ask questions about stuff. Is Littman a gymnast? Probably not. We expect a false. Is Littman a ninja? Absolutely. Okay, so we can ask questions about objects to say, are you actually one of these other things? Okay, so we can identify things, and that's certainly powerful in the context of inheritance. So for instance, if I had any instance at all, I had a string, I had a random object, I had a JSON value object, doesn't matter. If I said, are you an instance of object, the most generic form of any object, every single one of them would return true. Does that make sense? We think about our game last semester, everything in there was an object. We had a specialized version of object called an inhabitant. Most things were inhabitants, right? But if I had a player and I said, player, are you actually an object? Absolutely. In his heart of hearts, at the very top level, he is an object. He likes to think he's quite a bit more than that, but at the very least, he is that. Okay, so that's the instance of operator, and we'll be using that sum. Okay, go back into Eclipse here. So we saw that indeed our OBJ, this object here, is an instance of our JSON array, which we expected because as a human being, we looked at what that string looked like and we saw started with an opening square bracket, ended with a closing square bracket. That's an array of stuff. Okay, so our parser at the very least did a reasonable job initially of parsing that into a JSON array that we can hopefully now walk through. All right, so I'll just comment that out for right now. And here, I can even ask the question. Well, even though we know, we can say if just to kind of show you a real life example of when you might use this. We might only want this code to execute in the event that I'm dealing with a JSON array. All right, so I read in my URL, I went ahead and ran it through the parser, then I just asked the question. Is that object actually a JSON array? If it is, go ahead and do this stuff. If it's not, we're not doing anything. Okay, so if I'm only in this if statement, I am only in here if OBJ is a JSON array. Wouldn't be here otherwise, right? So what's the very first thing I do? Just for convenience, I go ahead and say, look, you were originally created as a generic object. We happen to now know that you're actually a JSON array. So I'm going to use this syntax called typecasting. And this is something that exists in Java, C, C++, C#. We did have it in Python, but we did it through functions. If we had a string and we wanted it to be an int, we passed it through the int function that turned a string into an int. Okay, so, and that's a half lie. That's not identical to typecasting, but I think for the final output, we can think of that as being accurate. Okay, so we have this idea of typecasting. Syntax is open parenthesis type var name this will attempt to, we're going to say, convert var name into whatever type is. This only works if var name is actually of type. In this case, we're saying, look, you're in a variable of type object. You're actually a JSON array. I can typecast you to JSON array. Like we did right here. So here's my variable name, obj. I'm saying I want you to actually behave like a JSON array because I know that's what you are. I would only be in this if statement if I knew that. Then I'm just going to create a new variable of type JSON array. You can name it whatever you want. I named it array here to hold you. That way, from this point forward, whenever I use array, I'll conveniently have access to all the methods that are in array. Otherwise, every single time I was going to want to call something, I would have had to do something like this. Dot add something, dot get something. I would have to say, look, object, you're actually a JSON array. I need you to pretend to be one here for a second so I can call one of JSON array's methods. If I don't do that, and I just try to say object, obj dot, he's only showing me the things that come from generic objects, which doesn't have all the fancy JSON array stuff in it, even though he is a JSON array. He's in costume. All right, so for convenience here, so I don't have to use a bunch of parentheses and stuff, I'm going to go ahead and say, one time I'll go ahead and typecast you to JSON array, and I'll store that unmasked version of you inside of this variable called array. So now that variable array is a JSON array. So now we're looking at kind of our standard for loop. I want to go through every element of a list. It's effectively what we're saying here. I is 0, keep going as long as I is less than whatever. If we know array is an instance of JSON array. JSON array, just like lists, just like any other kinds of arrays, they probably have a size or a length or a number of characters, whatever it is. It just so happens that JSON array has a method called size that gives us the number of elements that are in there. Okay. So let's just, I'm going to make something up. Let's say that we have 200 elements that are inside that array. We can actually count and find out how many are in there. In fact, that'll be interesting. All right, so each time through this loop, we're going to go ahead and get the current value from the array. And this was an array filled up with JSON objects, that name value pair type of thing. Okay, a bunch of curly braces with stuff in it. So I'll go ahead and get the current data associated with a card stored in this variable. And then I went ahead and I just printed out, I'll go ahead and print out card data here. I'm going to take it one step at a time. So I'm going to comment out this stuff for right now. All right, so the idea here is that I'm going to go through, I'm going to grab, this is information about a single card, one card from that collection of cards. And I'm going to just print that to the screen, just showing us what should be a single JSON object. And I'm also counting at the same time. So at the end, we'll find out how many cards were actually in there. 5,217 cards. I was off a little bit from the 200 thing. Okay, so here's an example of the last card we read through. So this is, Angoro is one of the card sets. Here's the artist, here's the name of the card, here's its ID, so on and so forth. Each one of these is a single, so this line right here got called 5,200 times. So this was the last time it printed out. This was the time before that it printed out. This was the time before it printed out. It's printing out a single JSON object that lived inside of that JSON array. All right. Now, when we think about our Hearthstone card that we had previously built, this guy, notice we built this guy in terms of cost, attack, defense, and name, right? So we kept it relatively simple. We see that there's a bunch of extra crap that we have in terms of data here that we may or may not use, but for right now, we know we have more data than we likely need. Now, I think I mentioned in class that attack and defense only actually pertains to minions, monsters that you might summon who are going to go fight for you. If you have like a spell that does something, it's probably not going to have an attack or a defense. I'm going to show you that as an example here. So if I go back out here and I'm going to go ahead and just say, look, instead of saying printing out card data, I'm going to say print out card data dot get. And let's go ahead and let's get the, well, we can get the name. Yeah, let's get the name. I think they all should have names. All right. So I don't want to get the whole object. I just want you to tell me the name of each of those cards. So I'm going to get 5,217 names printed out. It's possible we might get a couple of null values if we don't have a name for some of the cards, but I think largely we'll have names. So Crackling Shield, Living Spores, Spirit Echo. We have some duplicates here. I'm guessing that maybe there was from different versions of the same card. Sometimes they make changes to it. But in any case, we are only seeing the names of those 5,200 cards now. All right, make sense? Go ahead.
How could you get that information for just like one card?
Well, you just wouldn't go through the loop. So I'd come out here and just say, get me the card that lived at bucket 4. Instead of saying, go through all the cards. So this is just the object, the name of the object that lived at bucket 4 in our JSON array.
Oh, okay.
So what if you didn't know the exact bucket?
Well, you could search through it for name. Yeah, it's kind of, what we're doing here is we're investigating the tool. We went to Home Depot, we got this complicated looking thing, right? We came home, we threw it on the table, and we probably didn't read the instructions, right? And we just started messing with it, trying to figure out what it can do. So one of the things we can do is we can say, hey, print yourself out. Let me see what you look like. Then I can say, hey, a bunch of you seem like you have this thing called name. Why don't I just print out the names? Let's just see if I can get the names. What you're suggesting is, well, what if I'm interested in only a very specific card? For instance, Arcane Blast, right? So I can do something like this. Let's just, I can say if card data dot get name dot equals Arcane Blast. If I'm looking at that specific card, maybe tell me what his cost is for mana cost. Something like that. So now I'm going to potentially go through all the cards. Well, I will go through all the cards, but I'm only going to display anything if I'm looking at a card whose name is Arcane Blast, in which case I'll display that card's mana cost. Which I think Arcane Blast is like 0 or 1. 926. Oh, this is for something that didn't have a name. So I really need to write it like this. If card data dot contains key name and its name is Arcane Blast. Its cost was 1. So here's another tool. As we were messing around with it, we found another button that says, hey, if I push this button, it'll tell me whether this particular card we're currently looking at, the JSON data for it, JSON object, whether it actually has a name. If it has a name and that name is Arcane Blast, go ahead and print out that guy's cost. Make sense? And you see that kind of here. So now we're going to say, if card data contains a cost and it contains a name, if it has both of those pieces of information, a cost and a name, go ahead and give it its type, its name, and its cost. All right, so we go through here, we start seeing a whole bunch of different things. We see one thing that has a type called spell. Here's something called a minion. All right, minions have that health. Well, instead of defense, it's called health. So they have a attack and they have a health for a minion. So we're going to say, look, if you have a cost and you have a name and your type is minion, go ahead and give me your name, your cost, your attack, and your health. And you'll notice that those things happen to line up with the 4 things that we're interested in here. Cost, an attack, a defense, and name. But only if you have a cost, you have a name, and you're a minion. Because minions have attack and health. Other spells and stuff don't have that. So now here's a list of all the minions that are in that deck. Oh, why didn't I get the minion? It has a cost. Did I misspell minion? Oh, sorry. It doesn't contain a key called minion. It has a type. So we're going to say get actually, you know what? Let's put it inside here, just so we don't link these together. So we're going to say if card data dot contains key type, which they all should, and card data dot get type dot equals minion, then give me the name, the cost, the attack, and the health. So here's all the minions that are in there. Make sense? So your homework and I'm going to go ahead and say count plus plus in here instead of here. And then we'll print it out at the very end. This will tell me how many minions we had. 1,924. So initially, I'm going to go ahead and say, we have a Hearthstone card array called the minions. This is going to be a new Hearthstone, I know we're out of time, card array of size 1,924. I'll just cheat a little bit and hard code it. Your homework is to fill up this array of minions with Hearthstone cards created with this constructor with the data that we're reading in right here. Here's the name, here's the cost, here's the health, or here's the attack, here's the health. We have the 4 pieces of information there. So I'll put it, I'll list it as homework over here. Homework, given the current code from class, fill the array of minions up with instances of Hearthstone card using the constructor that takes the name, cost, attack, defense. Test the code by displaying all of the cards. Make sense? And I'll push this up to GitHub. Made changes. All right. I will see everybody on Monday.
Professor,
Yep.
I mistakenly forgot to submit the previous assignment on time, but I already make it at the Friday, Tuesday. So is it okay?
Is it not submitted yet, or you just submitted it late?
I submitted it today.
Okay, that's fine. It'll be okay.
Oh, thank you.
Yep.
Yeah.
What's up?
How you doing?
Good.
You know, my MacBook is one of the keys is starting to be funky.
Okay.
I know you and Bob had yours.
Yeah, they replaced the keyboard.
I don't know what to do. I mean, do I? Will they still do that under warranty?
I guess I don't know. I mean, we have Apple Care, so
Right. I don't
should
remember
be
when we got those.
well, it should be 3 years.
Okay. Okay. Should be okay. All right.
Well, am I still?